Hi, welcome to Physics 2.3. This is another helpful video for throwing objects up from a height. So remember, you have 10 variables to consider, that a lot of these are linked, and you have three primary situations. We're going to talk about the second situation today, which is given why not and why. So here's your situation. This is a linked question, so you have to be very careful to focus on whether or not you're going up versus going down. The first step is to find V naught, that is the square root of 2a delta y. Recall that delta y is y minus y naught. Then you have to use your V naught that you just found to find the time up. Now, that's the only part that is linked. Then you can find your time down based on your height, your velocity at the bottom based on your height, and the total time being time up plus time down. So, for example, Thor throws his hammer straight up from 45 meters. If it makes it to 90 meters before falling to the ground, at what velocity did he throw it? How long was it in the air? And how fast was it going when it hits the ground? Let's get started. I'm going to add a new equation so that we can do this together. The first thing you have to do is find V naught. V naught is equal to the square root of 2 times 9.8 times 45. Okay, now why am I using a positive 9.8 here? What you have to remember is that when you're talking about going in one direction and you have to take the square root, remember that your V naught is going to end up being positive anyway. So we're looking for the absolute value of gravity, not just negative 9.8. Grab your handy dandy calculator, and the square root of 2 times 9.8 times 45, the difference between 45 and 90 meters, is equal to, I want to be outside my radical, 29.698 meters per second. He had to throw it at almost 30 meters per second to get it up that high. And again, we are assuming we're on planet Earth, not his home planet. Okay. Then we want to find time up. And again, new equation, time up is equal to the fraction of negative 29.698 divided by a negative 9.8, which will equal 698 divided by a negative 9.8. Be sure your negative button, not the minus sign, is 3.030 seconds. That's your time up. So we have answered the first question, at what velocity did he throw it? Which, if we color code things again, if we go there, that V naught, okay, is that kind of peach color. And then how long was it in the air? We can't do that one yet because we don't have a time down. So, new equation. Time down is equal to the square root of the fraction of 2 times the ultimate height, which is 90, divided by 9.8. So, square root 2 times 90 divided by 9.8 should equal 4.286 seconds. Go back, put my equal sign in. 4.286 seconds. Now, if you wanted to, right now, you could find the total time. The total time is equal to the time up of 3.030 plus the time down of 4.286 to equal 7.316 seconds. Check my mental math there. Hey, I got it right. Good job. Okay, 7.316. So how long was it in the air? That is given by the blue highlight here of 7.316 seconds. Finally, then, we want to find the velocity at the bottom. Velocity at the bottom is the square root, VB is equal to the negative square root of 2 times 90 times 9.8. Okay, so square root 2 times 90 times that 9.8 should be 42 meters per second, and that is a negative 42 meters per second. So how fast was it going when it hit the ground? That should be given by that purple, which is a negative 42 meters per second. And that one did come out perfectly even when I did it. So double check that. Make sure it does work. Thanks for watching.